Esta conferencia comenzará a grabarse.
So first of all, I'm going to introduce myself. My name is David Blanco. I'm a MEP engineer from the Technical Support Department of CYPE. And today I'm going to be in charge of this webinar, this presentation about the HVAC, a little overview of our tools about HVAC design, thermal loads calculation, modeling, 3D modeling, thermal loads calculation, HVAC design with an open beam system, and if we have time, ducting design, and if we have time in the end, I will show you some energy and demand and consumption tools. So, well, if anyone has any doubt or queries during the presentation, do not hesitate to write it on the chat, or during the presentation, I will try to answer all your questions or your doubts. Or if you prefer at the end, you can ask me all the doubts or queries about the webinar. You could, well, ask me whatever question you have at the end, okay? So if you're ready, we can start with today's webinar. Do you know anyone know anything about SIPE or tools about our OpenBIM workflow, about our BIM Service Center platform cloud solution? Does anyone know anything about this, or is the first time you see it, or? If anyone can answer me by the chat, have you tried tested the BIM Service Center platform, or? Okay, so maybe okay, you know a little bit about the OpenBIM workflow, but you know, for you is the first time I see some people that is the first time you hear about the server. But okay, so I'm going to make a little introduction about what we're going to see today. So first of all, we have the OpenBIM workflow with our HVAC solutions, and in general every other structural MEP solutions designed by SIPE are based on this OpenBIM technology. Open because it's based on standard formats, IFC, DXF, PDF, XML, all standard formats, not native files. We are going to share all of these results in a BIM project with the open formats based on standards, on an ISO codes. And we are talking about BIM because it's a technology and a workflow that is based on a multi-collaborative, multidisciplinary, and multi-user way of working. So we are going to share. We are going to work with several software, several tools, with a 3D model, with a model in 3D of our project, and we are going to share the information in the cloud. And everyone is going to be in real time linked to this 3D model, and is going to design every specialized tool, every application in real time with this 3D model, and is going to be able to generate the technical documents, schemes, diagrams, drawings, cost estimating, reports, specifications, etc. So everyone is going to be starting from this 3D model. The architectural and geometrical model is going to consolidate this BIM model, including and improving it with the results of each specialized application. So in this manner, we are going to improve on this original BIM model, architectural modeling, with all the results of the different specialized applications. We establish the boundaries between each engineer, each specialist agent that intervenes in the project design phase, and we are going to make a progressive workflow and a progressive implementation of the BIM technology. So this is the idea. So we have this a 3D model. We will see you can work with other BIM modelers of the market: Revit, ArchiCAD, Allplan, Bentley, etc., SketchUp, etc. every modeler that's going to be able to generate IFC models. You can work with our modelers like IFC Builder. IFC Builder is a free and very simple modeler that we are going to see an example today. And with this 3D model, we are going to store this information in the cloud. We are going to be able to communicate with the different HVAC tools, for example, today, and we are going to generate the results and export the results to the platform. Okay, so this is the idea. So we are talking about this server, Beam Server.Center platform is going. We need this platform in order to communicate among all the agents that intervene in the project, all the team members of the project, all the engineers, structural engineers, MEP engineer, acoustic, thermal, electrical, etc. That everyone is going to be linked to this project, going to be part of it, and they are going to be linked in real time to the 3D model. So the platform, this Beam Server Center platform, it's a free platform. So you can register, you can create an account with this login option. If you search in Google or if you directly introduce this website, beamserver.center, you will find this website, and you could see some videos, some information here, and also you can register here. You can create an account. Only required an email. So you have an email, you register. I think most of you have already are already inside the platform. You have already an account, so you can. I imagine that some of you have tested. If not, I encourage you to do it. So if you click on here, login, you register with an email, an address, and you create an address, and you can start working with the platform. So I'm going to introduce my account. I'm going to access. And what we will see here, this is the aspect of the environment of the platform. Here we see some tabs, some paragraphs, projects, contacts, collaboration requests for other projects, or open projects in the platform, or closed projects in order to manage the invitations on the requests for collaborations, the store applications to download, some new features, news, and modules and licenses you have in your platform. So this is the Beam Server Center. So the idea is to have like a store application, like a storage platform, in order to a cloud server solution, in order to store and to create Beam projects, in order to collaborate with other people, create a professional network with other team members of your own office, of your own environment, or with international people, as you wish. So it's like a professional network. You can also search for certifications, international Beam Manager certifications, LEED, BREEAM, etc. We are creating partnerships and collaboration with entities of certification for many purposes. Also, you can search for job opportunities. If you are a specialist in some particular structural design or MEP design, you can search for open projects, some contractors, some potential clients that they have offer some projects, open projects in the platform. They are searching for some specialists, and you could also apply for these open projects, for example. So the idea is to have a network in order to search for job opportunities. Also, the store applications, in order to download and buy applications, there are free applications, payment applications. You can search them in this platform. Okay, so for example, if you search for today, for example, Cybertherm, you will see some applications for Cybertherm loads, for example, for HVAC design, for ducting design. These two applications we will see today. For example, Cybertherm Improvement Plus for energy audits, in order to compare results of energy demand and consumption and make an economical analysis. Also, some particular for the many countries for thermal analysis, etc. So, for example, another type of applications that are open BIM system. This is an evolution of the BIM objects. What we call BIM objects. It's like a manufacturer system, a global purpose application, in order to configure and design a global solution of a particular manufacturer. For example, today we could see open beam diking in order to design VRV installations or designs of diking products or diking objects. Also for air conditioning, VRV, sorry, aerothermal, etc. There are other manufacturers, for example, Open Beam Toshiba, Fujitsu, Midea also, etc. So there are many manufacturers that we are including in order to increase and improve the application. You have also education purposes for universities, for education campus partnerships we have for universities, and also the projects tab for professional use. For example, here I could open, for example, any project. For example, this one. This is the list of projects I have active in my account or file projects, and here we could manage all the information of each project. For example, the number of files shared in the platform, the number of team members. Also have a possibility to manage the quantity of files, the traceability of the project, the historical changes, who has changed something in the project, the latest change, the number of the type of file who has been changed recently, who has entered the project, who has left the project, etc. All the changes. Here's the number of files, IFC, PDF, GLTF, BC3, XML, etc. Work team, etc. Okay, so this is the information. Sorry? Well, why do you want to make a presenter? It's well, today the purpose is to have a presentation. If you want to make some questions, don't worry, you can do it by the chat, or even at the end we can open the micros. Maybe if you want to talk a little bit, okay? Perfect. If you don't mind, it's like this, okay? So we continue. For example, the files tab, we will see here the files. Here we have all the files of the specialties we have been designed here in the platform, okay? And all the fire protection, the sprinklers design mechanisms, structure, photovoltaics, HVAC, etc. For example, for sprinklers, here we have some designs, some PDF projects. This is in Spanish, or DWG files, etc. All the files have been generated by the specialist, the fire protection specialist, which applications has generated, and the number of files shared for this purpose of fire sprinklers. For example, in the dashboard, we could see also the 3D of this project. Okay, here I hope to see, let's refresh it, and if we can see the 3D design. Yes, if you have some question, yes, please go ahead. Here you have the 3D, for example. For this purpose, I'm going to open Guido. Here, for example, you have the architectural design. For example, here we could establish and make it a little bit transparent, the architectural, and we could establish, for example, the structure or the HVAC design. For example, let's go ahead with the HVAC design, for example, here, and the structural design. Here you could see the information of this BIM project. As you can see here, the structure calculations. Here we could see also some information about the elements. Okay. If I double click, I could see this is a foundation element with this typology, reference, material, Also for the HVAC installation, here we have an equipment, this series of equipment, this typology, the total power, nominal power, available power. Also for the piping, double click the pipe, the length, the diameter, etc. Okay, so for example, here is the column with this reference type, disposal, material, etc. All the information is available in files that you could open even in the own platform, or even with this graphical design in this 3D. Also, we could be able, for example, to establish some sections here. For example, if I use this tool, for example, I could see the internal design of the building on each floor with different planes, section planes, in order to consult the information inside. Okay, so there are many possibilities here. Yes, well, I'm waiting for your question. Okay. The projects tab is the projects that I have been creating myself. I have created myself as a creator of a project, of a BIM manager, or in which the project which I collaborate. For example, this one is one of my colleagues, and I collaborate in this project as a guest, as a moderator, as an editor, different roles. Also, for example, the file projects, ancient files that have been designed, and some past projects that I have been working on, I have created or working on, but they are already past because they are already finished. And also in the recommended projects, as I told you before, this is the tab where the platform has some kind of artificial intelligence in order to propose you as and there are some projects open in the platform, and they are recommended to you as according to your profile, your preferences that you can manage here. In your profile, you can manage the preferences of your location, your specialties. If you are a structural designer, if you are an MEP designer, which traceability of your number of experience, number of projects you have, the typology of project you have made, in which you have been collaborating. The platform is some kind of recommend you or suggest you as a specialist for some kind of project that are open in the platform. Okay, so this is we are improving. Okay, but this is a recommended projects tab in order to search for job opportunities. Okay, so let's start. I'm going to create a project. Okay, and I'm going to invite, for example, Vincent, my colleague. I'm going to create a project today, for example, webinar. Okay, HVAC. Okay, and we are going to set like, for example, it's like other purposes, like educational, for example, and I will see, for example, visible to my contacts. For example, I could establish here. Do you have some information about the visible to all the users in the platform, to all the users even outside the platform? You can share, and you can share to anyone by your mobile application, or by internet, by a link, or you can share in the BIM server only to your contacts, or not visible for anyone, just for you, for your purposes. Open to collaboration requests to your contacts, for example, where different management of collaboration requests, and example HVAC, for example. Okay, I'm going to create a new project, and now I'm going to invite, for example, Vincent, my colleague, and he, even if I assign him a role, a particular role, he can invite you as a guest or as a editor or something like that if you want to complete it. For example, this is obviously is blank. There is no information here. The management, this is the work team, only me, proposed IFC files, latest change. So I'm going to work team, and I'm going to invite a user, for example. Here we could create team members, group members, etc. For example, I'm going to, yes, it's here, Vincent. I'm going to click on next. For example, I can assign him as moderator, for example, and there are some different roles depending on your project you are creating, and the roles of configuration you want to create in your own project. So you can create moderators. It is only collaborators if you want to approve. For example, you can create different collaborators, and in this purpose, you can establish some people in order to approve their work or not, if you want to approve their work or not before introducing in the platform. Okay, so which areas I'm going to assign? For example, imagine fire protection and lighting design, for example, for Vincent. Okay, I'm going to click on next, and I'm going to invite him. Vincent, let's, for example, start working. Okay. I'm going to send invitations. He's going to receive an invitation via email or via the application, the mobile application, and he's going to enter the project, and he's going to be able to invite other people, or I'm going to start developing the areas that I have been attributing him or assigning him. Okay. So this is the way to create a new project. So let's start now with the applications, CYB applications. For example, as I told you before, in the store you can search for the applications. You can download and install applications directly from the platform. For example, you're going to see IFC Builder, Cyber Loads, HVAC, etc. They're all here. Or even in our website, you could see the platform in our website, www.site.com. You could see the whole suite that we have here. For example, I can show you here. This is the whole suite of CYB English. There are not only applications. For example, the OpenBIM systems are not here because they are so many here. So here, for example, you can search for IFC Builder. We have here a free plugin for Revit. In order for those of you who work with Revit, we could start your work directly in Revit, and you can start your 3D design in Revit and communicate with our tools. Okay. So, for example, Cybertron, we have Cybertron loads also here, HVAC, E+. For example, there are 3 important tools in order to calculate, analyze the thermal load design. Also, you can see these tools in the store application of the BIM Server.Center. Okay. So let's start with IFC Builder. As I told you before, remember this workflow. Remember, in this icon, we have to create a 3D model in order to start this OpenBIM technology. So in this case, instead of, because today is overview is not with this, well, I'm going to show you quickly. You could create a new file, for example, a new IFC file. And also, for example, if I create a new file, well, sorry, I'm going to show you how to create an empty job, a new project, an empty job, in order to model it. This is a very simple tool. I encourage you to test it, to see all the tutorials we have on internet in order to create this IFC Builder 3D modeling. Empty job, and here we could establish the number of floors or groups of the building, number of above the ground floor and below the ground floor. We could add the number of floors or groups and the height of each floor, the reference of each floor. It's very simple in order to configure your building. And here we are going to attribute a template. For example, I'm going to click on yes. We could, in this window, sorry, because I have 2 screens here, template view manager, I could add a template view manager, and we could, for example, search for a template in DXF DWG. For example, you could search DXF DWG files, GPG also, image files, or PDF files. For example, here we have in MP English, we have like a dwelling, for example, a detached house. This is a DXF, very simple DXF file. And here I can attribute to this floor, for example, the ground floor, this DWG file. I could show you just simply how to introduce a constructive element. Here, for example, I have to activate the template, for example, here. Okay, this is it. This is the environment of IFC Builder. And I have to set the orientation. This is the north. okay, of the orientation of the building. And here we have the possibility to start introducing architectural elements, for example, walls and partitions. I could show you how to introduce a wall. For example, external wall, I can introduce. This is only the architectural model, the geometrical model, not information of layers, no material, no layers, because the layers and the materials are going to be set or established afterwards in the Cybertron loads or E+ or HVAC calculations, okay? So let's introduce, for example, 20 centimeters wall, and I could, for example, follow this contour line. Even I could do it approximately by hand, or even I could activate the object snaps if we want to be accurate. Okay, there are many possibilities here in order to be the ortho mode and etc. So this is the way to introduce a wall. Okay. Also, we could do it the same thing with internal partitions. For example, partition 1, 7 centimeters, for example. You could manage and modify the units. You can work in international system, IP system, where as you wish. For example, ortho mode, we can force the unblock the coordinates more or less approximately. This is like the walls. We could activate or deactivate the template at wherever moment I want. And in this, for example, in this place, I have introduced like a room. This is like a bedroom, for example. I can create a space, new space, for example, bedrooms, okay? And I could introduce the reference here, bedroom 1, for example. This is a bedroom. I could even introduce a window, for example, with openings. For example, here an external carpentry and glazed openings, window 1, for example, with the width is going to be taken from the plane, from the drawing, and here it's 1 meter height, for example, and 1 meter above the ground, for example. And here we have a window, okay? For example, another one over here. Even I can adjust the position of the window according to the wall, okay? As you can see here, for example, okay? So this is the idea, okay? So, for example, a door, for example, another thing, a door, I could create a new typology of door 1, with this width and height. I could establish here one door and another one, for example, here. Okay. This is it. And finally, for example, how to introduce our floor slab. For example, the screed or the slab on ground floor, for example, the screed 1 with 20 centimeters width thickness. And I could introduce, for example, this element, for example, on this contour line. So this is the way to introduce some quick elements and constructive elements, how to model. We start in 2D dimensions. Here you have object snap, layers. Here on the right, on the bottom right of the screen, you have the basement. For example, here we are in the basement, but we could also go up, and this is the ground floor. For example, maybe I could copy from the other one, copy group from the basement here, and I could modify, for example, here in the floor slab, I could modify this script an internal floor slab and create a floor slab, for example, for this purpose, and I could modify this. And in the 3D view, I could save the changes, and in the 3D view, we will see the building created in 3D. For example, sorry, because I have it in the other screen. So this is it. This is the simple, quick elements. I have introduced some particular external walls, internal partitions, the doors, these windows, and also this screed, for example, the slab on ground floor on the basement, and an internal floor slab, as you could see here, in this floor, in the ground floor. Okay. This is the way to introduce. Here we have some particular elements that are very nice. For example, here you have, well, I will show you in the other example. So this is the way to create a just very quick way to introduce a new project. So you have many tools here: walls, floor slabs, columns, you have the introduced spaces, group of spaces, and nearby buildings, obstacles. So I'm going to open an hotel. For example, this is an example you have included in the here in the, for example, in the file tab in here in the main window, for example, sorry, here in the main window of the IFC Builder application, you have file and you have the file manager. And here you can manage all your projects, all your native files, 3D modeling, and you have all your examples here, the examples files. If you want to open it and work with them, test it, etc., you can install it and you can install them and you can work with them. For example, this is the hotel file. And the hotel in the 3D view, you will see that this is a very more complicated project than the simple dwelling I was introducing. This is the hotel project. This is a five-story hotel, as you can see here. And here, what I was going to show you, for example, this is very nice. This is the shadows tab. Here you see the ground. For example, here we could establish the orientation according to the orientation of the building, and also the latitude according to the latitude of your location all over the world. You could establish for example, the position, the sound path of your building. For example, here you have the sound path according to this latitude. You have some buttons, add buttons in order to configure the orientation, and we can change the solar hour, and the sun is going to be moving according to this solar hour, according to this latitude, and even we can go to a particular day, a particular month, or even for a particular solar hour, I could establish a simulation in order to see the sun path and the shading trajectory for the building. Even I can modify the position of the sun path, and the software is going to analyze. This is very good in order to MEP design or thermal designers and architects, in order to see how the thermal performance of the building is going to be according to each orientations. We could establish some shading devices for windows, for some protection, some nearby buildings, in order to protect our buildings. Okay, this is how we can do it. Okay, this is it. We can just have many tools here in order to enter the building and go ahead inside and see the internal part of the building. For example, if I go inside, I could enter here and see the internal design of our building. For example, I could enter here and move the position of the camera. Here, I could enter the building and just go ahead and along the building and go inside and see all the design inside my building. Okay, so also you have, let's come back. You have also the possibility to go ahead and some section plans of your building design. Okay, this is very nice. Okay, so this is IFC Builder. So we have introduced our building. This is a multi-story building. With these icons, you could go ahead the different floors. Okay, of the building, you can go inside. Remember that we work in 2D with templates, the XFDWG templates. We model in 2D each floor, each group, and finally we are going to generate the building in 3D. Okay, in order to configure and create a BIM model. Let's export this building to a platform. So in this, as you can see here, I'm connected, logged in with my account, the BIM Server.Center account. Remember the platform before the platform, okay? In my projects tab, and here we will see the file we have created, the webinar HVAC for today, the project we have created. So in IFC Builder, I'm going to export this 3D modeling to this tab. This is my account. I could create it from here directly from IFC Builder, or even if you start with Revit or ArchiCAD, with Revit, you could use the plugin, the OpenBIM complement for Revit, and you could create the project directly from Revit, or even from the platform, or from IFC Builder. We can select the project, for example, and I can select from my account the webinar HVAC project I have just created just some minutes ago. So let's go ahead, webinar HVAC. I'm going to accept. I'm going to create the 3D model. Okay, this is the IFC file. I'm going to generate the templates because there are no templates here. This is an example without templates. I'm going to generate automatically from the modeling. But if you have template, you can export it, and also you can export the quantities. All the quantities of the different constructive elements, you could also generate it. I'm going to accept it. In fact, I'm going to show you now, because the software can analyze here the geometry of the building, just in order to get this net surfaces, the volumes, all the areas, and all different constructive elements. You could create them here. Okay. So this is, as it is a 6-story building, it's going to take a while in order to generate the IFC file in order to export to the platform. Meanwhile, there is another important tool apart from the here you have, apart from each application you're going to work with. This application is very important. Also, you have the Synchronizer. This is the Synchronizer. This is the application that allows us to communicate, in order to communicate all the platform project with all the tools, side tools, in order to synchronize the projects, okay, according to the different, among the different agents of that intervene the team members of the project. So this application is here. This Synchronizer obviously is a free application, like IFC Builder and like many other applications of CYP. This is the Synchronizer. I have downloaded and installed it. Even also, when you install any application of CYP, it's going to be installed automatically. This is my account. This is the number of projects I have here. And also, for example, I could get rid of this. There are many projects here. For example, let's unselect all. I'm going to only activate the webinar HVAC or any other, for example, well, this is a test hotel I did it before, for example, only these two webinar HVAC, okay? As you can see here, it's automatically synchronizing the model with the platform is going to export it, okay, with the synchronizer. So I'm going to minimize it, and I'm going to go ahead and refresh the project tab. And now we will be able to see the 3D modeling here. As I can see here, there's one file with 15 megabytes, IFC file. And also you could see in the platform, the hotel is already here, it's generated. This is an IFC file. I don't know which software has generated it. I don't mind. I don't mind if it has been generated by Revit or by IFC Builder or by ArchiCAD or Bentley. I don't mind. I only need an IFC, a modeling 3D IFC file. So this is the IFC file, hotel 3D model with a GLTF file in order to communicate with, visualize or view in every viewing tool. This is the IFC Builder generated by me. In this case, imagine that I'm creator of the project, the BIM manager, and the DWG files being generated automatically by the 3D modeling, okay? And the work team, remember that my colleague is Vincent Casal. Also, there are some other people that have been invited by Vincent already now included in the team, okay? So let's start working. Once we have already the exportation, what I was going to show you the results tab in IFC Builder. I'm going to analyze it, and I'm going to show you the geometrical information. For example, for each room, you could see the build surface, the typology, which group of spaces they belong, each room of the building, the net surface, the volume, etc. In order to check if anything is mistaken or something like that, you could check it here, okay? Also, you could consult the edges. The edges for the thermal bridges, this is very interesting, but because not every BIM modeler of the market is going to generate automatically the edges, so you have the possibility to generate or show it here. So let's go to the site thermal loads tab. In order to obtain, before select equipment and go ahead with that HVAC design, we need the thermal loads, the peak load calculation according to an SRI method, RTSM method. This is a very commonly worldwide used method for thermal load calculation. So we are going to launch this software, Site Thermal Loads software. Okay. So this is a thermal loads calculation. We here with my account of BIM-server.center in order to synchronize the projects. So I'm going to create a new project. Remember now you have to imagine that now I have changed roles. Now I am the responsible of the thermal loads calculation, HVAC design, etc. Because the BIM manager has well charged me of these purposes of this task in order to create this or to design this HVAC installation, ducting design, and thermal loads analysis. Okay, so webinar, for example, loads analysis. Okay, so we are going to accept. This is my local folder where I can work. We can browse and modify the repertoire or the folder where I want to store my projects, my thermal loads analysis. I'm going to accept, and now the software is going to ask me if I want to if I want to select a project from the BIM project or a manual introduction. Normally, the main purpose and the main advantage of these our tools of our open BIM technology is to start from an open BIM format file, an IFC file from a open BIM project. So I'm going to select a project from my list and I'm going to search for this webinar HVAC project. Okay, this is the webinar HVAC. Today they changed today. I'm going to accept, and now here going to wait a minute because I have to move the window here. Okay, it's reading the elements, so I cannot move the windows, not yet. Okay, just 1 second. Because the idea, meanwhile, the software is reading the BIM model because it's a huge building. So, okay, I have it here. So this is the building. This window has taken a little time because the building is not very. It's a really huge building. Okay, so this is the hotel, the 3D hotel. And here, what I was going to remind you that we have created a BIM project, in order to summarize a little bit. We have to create the team members. We have to we have designed the 3D model with IFC Builder in this case. We have generated the IFC file of the 3D model, and we have exported this IFC file to the BIM platform, the BIM-server.center platform. And now we are going to read this BIM model in order to analyze the thermal loads. So here is all the information we're going to read. This is very important, the typologies of libraries. This is, for example, this is my typologies of libraries. I've been working on other projects for walls, internal partitions, slabs, constructive elements in general, also spaces and other elements, okay? So this is the libraries. Once you are going to work with the software and with the different type tools, you are going to create your own libraries. And the process of reading and introducing data is going to be really speeded up, okay? Because you have already a library. So we are going to accept the environment, the work environment of the graphical interface is going to read all the elements of this hotel. Obviously, as I said, as it is a little much more complicated building with a 6-story building, we need a little bit. The software needs a little bit of time in order to read all the shades, all the shading devices, the constructive elements of the building. So it takes a little bit in order to read it. Do you have any questions for the moment, or everything is more or less clear? Do you follow me more or less for the moment? Yes, go ahead. If you had any question, meanwhile, it's going to read the shading generation. If anyone else has any other doubts or queries, you could also write it on the chat and I will try to. Okay, so there was a what if I change something that is modified by someone else? Does the model accept me or him? Well, the idea of this workflow is that on the level of modeling, for example, only the responsible and the owner of the project, for example, the one who has made the sport of the beam model, of the geometrical 3D model, is the only responsible of changing the 3D model, the architectural modeling, not anyone else. For example, from all the team members here, that only the 3D model, the architectural and geometrical model, that's only me, the only one responsible of this 3D model. That means that it's only me that can modify it. So if the thermal engineer or the MEP engineer or whatever specialty is going to generate or design in the BIM project, you have to inform the BIM manager or the creator and the owner of the 3D model. And if you need, for example, a wall with a higher thickness, or if you need more space in a room for any purposes, you have to inform the BIM manager. He or she has to update the BIM modeling and also update the BIM modeling in the platform, and you should update your specialized application tool in order to see that changes. So the idea is to be linked in real time with this platform, to be linked in real time and to be able to change in whatever time this modeling, but only for the different specialized applications going to be responsible for each particular agent that is going to intervene in the project. Okay, so it's not everyone is going to be able to change this IFC file or whatever IFC file for fire protection, electrical, or HVAC. Okay, so this is the idea of this workflow. So at the end, if we have time, I will show you how to make some design or some change here, and you will see how to update the model in the different specialized applications. Okay. So, well, as you can see, it takes a little bit of time to make the shading generation because it's a huge building, but we need I don't know if I answered the question. It's clear. The question about the changes according to the model, who is in charge and who is responsible of the changes in the model in architectural, overall in the architectural modeling, and afterwards in each specialized application. Okay. Is it clear? That's the thing. Okay, perfect. So this is finishing. Normally, if we have much more simpler building, it's going to take just a few seconds in order to import this BIM model. It depends on the size of the building that you will have to take some more time or less according to the size of the building. So now we are in this workflow of the technology here. We are now in this process. We have created a 3D model. We have exported to the BIM Service Center platform, and now we are here in one of the specialized applications, in this case, the thermal loads analysis, and we are importing this BIM model in order to make our analysis of the thermal loads calculation. And afterwards, we are going to incorporate this thermal loads analysis to the BIM Service Center platform. Let's wait just a few seconds in order to finish this importation of the shading generation. Obviously, it's optional to import the shadings and the edges. For example, the thermal bridges, according to each country or each part of the world, some countries or some codes, national codes, implies the obligation or to import the thermal bridges, but others not so important, and you can get rid of the thermal bridges. So it depends on each one of the situation according to the national codes or the situation of each country. So this is the aspect, the environment of the thermal loads. Here's the BIM model, as you can see here. Okay, and here we have the building tab with the libraries and the project. Normally, with an import of the BIM technology, we are going to be only be able to what we need to do is to provide all the constructive elements and all the layers, materials of the different constructive elements and the spaces. Okay, for example, the spaces, we have some spaces already defined. For example, here an unconditioned, because it's also it's already remarked here in the building. As you can see here, all the unconditioned spaces or rooms. Here you have to edit, and this is unconditioned already defined because I have already defined in previous projects. For example, I have toilet here. In previous project, I have this toilet library, and it's only heated, occupied, and with this criteria of internal gains, ventilation, cooling, and heating. In this case, I'm going to be analyzes only cooled. Okay, for the latitude you are, for example, today we are going to simulate a building, for example, in Vietnam, and we are going to calculate and analyze only cooled. This is the criteria of internal gains, ventilation. You have schedules, even, for example, to create your own schedules for each daily profiles. So you could create as wherever you want to do here for your own daily profiles for occupancy, lighting, ventilation, internal equipment, etc. You can create your own libraries of daily profiles as you wish. Okay. We are going to accept toilet, a room, hotel. This is not defined because this is the reason why we have this mark. So we are going to define it. Only cooled, for example, the ventilation is going to be, for example, 8 inches per hour, 1.2, 8 inches per hour, for example. You could establish heat recovery or not, schedules, or even you could consult the information of ASRAE standards. Even if you have no idea which parameters or internal gains you have to provide for each typology of room, you could go ahead and go to consult here for hotels and motels for the criteria of that is provided in ASRAE standards. You could even design here. For internal heat gains, we are going to provide, for example, people. Let's imagine 2 people for a typical standard hotel room. Sensible heating 90 watts per person, 70% of radiant fraction. If you have no idea, insist. You have all the criteria for the handbooks, handbooks or standards. 60 watts per person for latent heat gain. Internal equipment, if you have some refrigerator or something like that, for example, 50 watts. Radiant fraction is going to be 60%, and the latent is going to be 40 watts, for example. And the lighting is going to be, for example, a square watt per square meter, for example, 10 watts per square meter. Radiant fraction is going to be 80%, and the space fraction is going to be 90%, according to if you have a sailing, suspended sailing, or something like that, in order to the lighting criteria. If you have no idea, you go ahead to the standards ASRAE and you import the data from the ASRAE standards. So once you have imported, you have the information already defined. Corridor, for example, let's establish only cooled with this ventilation criteria, number of people, machinery room not conditioned, office, cafeteria, etc. For example, let's check only cooled, the cafeteria only cooled, also with the different criteria I have used in previous project. Okay, only cooled, the laundry only cooled, and finally the lobby, it's only cooled because only the lobby of the hotel, and well, people per square meter, for example, and this one. Okay, once we have established all the typologies of the spaces, the mark has disappeared. So let's move on to the next remark, the facades. I have to provide the layers and materials of the different facades of the building. Here they are already marked here, the main facade of the building. I have to edit here and configure the facades of the building. If I have edit here, this is the facade. And we have the possibility to create a simplified input with the global parameters, a detailed input layer by layer and material by material. I can create my own materials. I could create my own libraries of material with all its technical data from a manufacturer or a local supplier, for example, or even I could introduce some of these libraries, Spanish, Portuguese, French, international libraries, or as RISE standards, as you can see here, for gypsum, boots, masonry, insulating, etc. So you could create your own libraries of walls and materials, and you can introduce in series all the materials and layers. And also, there are these two possibilities: detailed input, simplified input, or introduce a library from this manufacturer, URSA, this insulated manufacturer, or from ASRAE. From ASRAE, we have these representative wall types from ASRAE, from the Handbook of Fundamentals. And we have, for example, freak walls, this typology of this U value of the walls, and we could accept here and all the layers of this wall. If I accept here, I will see the information of layers, the thickness of each layer, the total thickness, and the thermal descriptions. Overall, the U value and the thermal capacity. I'm going to do it the same with the different elements. For example, these P3 elements, I'm going to import from the ASRAE, from a concrete wall, for example, with this element. This is a concrete block, for example, for this lightweight concrete block, for this P3 typology of wall. P1, for example, the same thing. I'm going to import it, and from concrete wall, the same one, and accept here. I could create a export from libraries, import it, or copy the characteristics from the different elements. So wherever I want to do. For example, I could copy here from this one and to the rest of the walls. For this one, for example, I could edit and import from the libraries, from another construction brick walls, the first one, for example, and I accept here. P2 is going to be the same from concrete wall. This one, the same, okay? Instead of doing manually, if you have time, obviously, in your own project, you will have to create your own libraries of solutions, construction solutions. You use the ones from the ASRAE standards, or even you could create manually with your technical data, your own materials, or the ones of the libraries you have. Even, for example, all these libraries in the future, if you need further libraries, for example, if you have in Asia, for some particular Vietnam or Hong Kong or wherever other countries, Bangladesh, your own libraries, we could introduce the flag or wherever libraries you have in your own country. You can implement it here. And finally, this wall, concrete wall. Okay, so once we have created all the walls, as you can see here in the 3D wall, the mark or the warning has disappeared. Well, let's do it the same with the partition walls. For example, the partition walls, I have here the window. Let's do it the same. Here we have the window, the brick walls, for example. Let's imagine, for example, with this one, okay, with this solution. And for example, here we have the P1, okay. We could edit here and we could import from a brick wall. Another solution, okay, before. Let's import from another constructive solution, for example, concrete wall, this solution. Okay, we accept here. And finally, the P3, the same one. From a concrete wall, for example, for this one. Okay, this is the solution for internal partitions. Let's move on to the underground walls. Here we have to edit. And for example, instead of importing from ASRAE, we have to create, we can create manually, or I could import from any other previous solution I have introduced in previous project. For example, this one from a French solution I have in concrete, for example, for this solution, for underground walls. Slab on ground floors, here we have this slab on ground floors, and I could edit here and import from any other solution. For example, from my library script, this script I have to accept here, and I will have this solution for the slab on ground floor for the hotel. Another typology or another element, the roof, for example, R2, it's already defined from a library, a previous library I have in my library, R2 with this concrete roof or flat roof I have for this part of the building. And the R1, this is the solution. I could edit here and introduce manually the same thing on the same way I have shown you with the vertical walls. And here I could create, for example, for roofs, yes, from ASRA standards, we have also particular solution or typical solutions for predefined. For concrete roofs, for example, we have this solution, concrete, with this U value and these layers, the built-up roofing, the fiberboard, insulation, and heavy weight concrete layer. This is the thermal description and the thermal capacity. Okay. What else do we have? Well, as you can see here, once we have been completing the different constructive solutions, we have to continue with the rest of them. The doors. Well, sorry about it. Apologize because the references are in Spanish, but there are doors, internal and external doors. Let's introduce. Edit one by one. This is an internal door. Let's imagine this is a boot door with a U value of 2 watts per square meter per Kelvin. This is a fire break door for in the steel or aluminum or whatever, in steel, in this case, galvanized steel. For example, 4 watts per square meter. This is the lift doors, as you can see here, 4 watts, for example. Another lift with different dimensions, as you can see here. The rooms, hotel rooms, for example, 2 watts. There are, imagine that the boot boot doors for the different rooms of the hotel. The lift, another glass door, for example, and another glass door for an internal room, for example. Let's imagine this is at 3 watts per square meter. Another glass door. The garage door, the metallic, this is the steel or aluminum garage door. For example, let's imagine 4 or 5 watts per square meter. Finally, another metallic door for the technical rooms, for the technical room, the machinery room, for example, 4 watts, steel, aluminum, and 4 watts. The absorbance, you could see modify the color of the absorbance of the different constructive elements for the doors. Okay, so these are all the elements for the doors. And finally, we have the glazed openings, all the windows with the different opens of the windows. If there are with the different systems, if I edit here, I could it's obligatory or is mandatory to configure the different glass of the window. Glazed fraction is going to be, for example, let's imagine 2.5. Simplified input for the glazed solar heat gain. The opaque fraction, let's imagine it's going to be, for example, more or less 20%, and 4 watts per, like with thermal breach, for example, for the aluminum with thermal breach for the glazed opening for the carpentry, for example. No external shading and no internal shading. If you want to provide some shadings in order to reduce the cooling loads, you're going to simulate some shadings, as you can see here. I could establish some shadings, all the shading devices for the windows, and for the internal shading, like a blind or like a store or something like that. Okay, let's do the same with the rest of the windows. 2 watts, for example, 20%, and 4 watts for the aluminum. Okay, 2 watts, 4 watts for the aluminum carpentry. The same one here, 20%, 4 watts, 2 watts here, and the opaque fraction here, 4 watts. Okay, here, for example, 2 watts also, and the opaque fraction is going to be 4 watts also per square meter per Kelvin. And finally, we have the 2 left, 2 watts. I'm going to simplify in order to, all the windows are already the same solution for the glazed and for the carpentry, really. Okay, 4 watts per square meter per Kelvin. Okay, so this is it. All the constructive elements, all the libraries of spaces, rooms, and constructive elements are already completed. So what we have left here in the project tab is only the information for the different spaces, which are defined, which come from the design of IFC Builder. Non-conditioned, all the non-conditioned rooms, all the different ground floor, floor 1, 2 floor, the groups of spaces for each room. Here are the information, the geometrical information, and the different elements, walls, floors, openings that comes from the BIM model. So normally we don't have to do it, we don't have to do anything here because everything is taken from the BIM model. So what we have to complete really is the libraries, the constructive elements, the spaces of the building. So for the linear thermal bridges, in this case, I have imported the edges from the BIM model in order to take into consideration the thermal bridges. And here we have to process. We have edges processing. We can configure the edges processing. There are some criteria, some ISO codes, some Spanish codes, French, Portuguese codes, or some numerical analysis from finite element method analysis, okay, for these calculations. And also the manual definition for internal or thermal transmittance, okay? The manual definition if you want to configure a particular linear thermal transmittance for a particular thermal bridge. If I import here, I will be able to accept and process all the edges of the building. So this is the information of all the edges, the thermal transmittance, the linear thermal transmittance, and if I accept here, so the software has cleaned a little bit all the edges of the building, only taking into consideration the ones are usable in the building for the screed in contact with the soil, the balconies, or the floor slabs with the facades, the intermediate floor slabs, the outgoing corner or the ingoing corner, etc. Okay, so the different solutions and also the windows. So this is it. So once we have configured the building tab, we can move on to the thermal loads tab. Let's go to the thermal loads and make the thermal loads analysis. So remember, we used this software in order to make SRI thermal loads analysis. First of all, we are going to establish the location data because remember here in IFC Builder, we have designed the BIM modeling, but we have established the orientation, but not the location of the data, the location of the building. The location is going to be set here in thermal loads analysis. So here we have the possibility to introduce all the outdoor conditions handily with all the latitude, longitude by hand, and you can create your own libraries, or you can import from Azure Weather Data Viewer. This is a huge weather data climate database from all over the world. So this is very important and very commonly worldwide used. And for example, in Asia, let's move on to, for example, Vietnam, and let's pick up, for example, I think this is the Ho Chi Minh, the capital, no, the international airport of the capital. Okay, so for example, let's take the outdoor conditions from the ASRAE weather data big weather ASRAE climate outdoor conditions database, and we are going to accept here, and the software is going to import all the data from this database. This is what you mean, the latitude, longitude, and all the data. Even though you import from this database, you can modify and change the temperatures, humidity, or the clear sky optical depth, etc. Even you can modify, customize it, and export to the libraries. We accept here the climate conditions. Here we can manage the calculations for heating and cooling loads, and we're going to accept, and let's create a hypothesis of calculation. In this case, we are creating different thermal zones. ones for the non-condition zones. This one, for example, is going to be non-condition. Okay. Another thermal zone for example, the ground floor. Okay. If I edit here the space selection, ground floor. Okay. Another one thermal zone in this hypothesis is going to be floor 1. Let's go ahead here and let's establish floor 1. You could even group in just one, the whole building in one thermal zone if you want to calculate only the whole building in one hypothesis, in one thermal zone. Floor 2, for example. Okay, edit here and import floor 2 spaces. Floor 3. Okay, if I edit here, sorry, floor 3. Okay, we have only 2 left, I think. Floor 5. Sorry, floor 5, for example. Floor 4. If I edit here, yes, I forgot it. Okay, so this is it. Okay. Well, I'm going to display the words. Okay. This is it. I'm going to save it. This is all the different thermal zones of my building. Let's calculate and analyze the results. If I have the results, the software is going to take just a few seconds to analyze the whole building and to calculate the cooling loads of this hotel divided in one hypothesis and different thermal zones in order to provide afterward the HVAC equipment selection. Okay, so this is, well, there we have also a lot of complete reports for each zone. For example, the floor 1, the floor 4, for example, the cooling load report. Here you have the cooling summary and space by space. For example, if I go to a particular cooling loads space, this is the floor 4, room 401, and we have this parameter data entry data with the conventional heat gains, losses, sensible loads, radiative loads for the internal partitions, the external partitions, thermal bridges, heat gains according to the external windows, internal doors, the solar radiation according to the window. As you can see here, internal heat gains, occupancy, lighting, internal equipment, and this is the total cooling load for this particular space. All the reports inside you can share in PDF via internet with a colleague, with a client, with a customer, with your responsible, the BIM manager, or even with us, with the technical support department. You could export in different formats: PDF, docx, TXT, HTML. If you want to customize it, to present, to introduce to your customer, to your BIM manager, or whatever, or even if you want to customize or personalize as you wish, you can put it in paper, in PDF, or whatever you want to do. Also, you could see some graph cooling load, hourly cooling load for January for each month, the progression, the simultaneous peak load for the zone. Even if you go into detail for each room, you could go to a particular room and consult the RTF parameters, the overview calculations. This is very, very, very cool. For example, for ventilation, we could go the overview calculations for ventilation, which criteria we use for the sensible loads and the latent loads for ventilation. Well, thank you for the comments. Yeah, it's very, very, very nice. This software for thermal loads calculations is very, very good. And it's, as you can see, we have to introduce, once we have the BIM model, we introduce the layers and materials, and then we obtain all the internal calculations, the thermal loads calculated. This is very, very good. Yeah, I appreciate that you noticed, you realized this. Thank you for the comments. Okay, so this is, well, you could see all the reports. The complete reports here, the cooling for each zone, particular zone, or ground floor, floor 1, etc. Okay. So This is the cooling loads summary. So you could get this is what we are going to use, the peak load for each thermal zone in order to select the equipment, the HVAC, for example, the heat pump, or the cooling equipment, or the VRF equipment outdoor unit for the VRF or the VRV, etc. And for each one, for the individual peak load for each space of the zone, we are going to use this one for the selection of the internal units. So we are going to export the results in IFC to the thermal loads results to the BIM Service Center, the project, the BIM BIM project. Remember that we are going to consolidate the BIM model with the project. Okay. So the export is completed. Also, we have some external, some additional. This is very good. Also, is nice. The description of materials of the building, because this is some quantities design. For example, the description of material, this is some extra report that is going to provide it by the software, for example, the facades or the roofs. Here, the roof, there are 2 roofs. This is the total surface area. This is some quantities that is going to be very, very helpful for the architects and for the designers in order to provide some quantities with the design, the section, and the properties, okay? The external floors, square meters for the R1, the F1, etc. with the insulation. Okay, so there are some really good information here. And finally, you will have all the materials used in the building, all the layers with the conductivity, the thermal resistance, the density, thickness, etc. Okay, and you could export, share via internet or whatever you want to do. Okay, this is really nice, and you have here some extra reports and here in the calculations. Yes, for each room, the software analyze for the whole thermal zone and for each room of the building. Yes, in a specific amount. Remember that we use an hourly method from ASRAE. The RTSM method, this is an hourly method. Each hour of a particular day for each month, monthly method. So this is a particular calculation that we do in order to analyze the whole building. This is, I encourage you to test it and you will realize that it's true. I'm not invented it. You could see it. I encourage you to do it. Okay. So let's go to the BIM Service Center platform. Remember, I have exported the results in IFC files. I'm going to refresh it with Control F5 of my shortcut of the keyboard. So we have the thermal loads analysis. This is the IFC results with the thermal layers. Remember here, this is nice also because we have the 3D. We have also the thermal layers in GLTF for the whole building in 3D. This is also nice. Here, if I make transparent this or even invisible, I could activate the thermal loads elements and we could see this in 3D. For example, I could open it wider, for example, in order for you to see it. Okay, so let's deactivate the 3D model and only the thermal loads layers or models of the building. Okay, so this is the thermal model, and this is nice also because we could even consult the information in 3D. If I click on a particular element, if I double click, I will see the R2 roof element with the total thickness and the thermal resistance. But if I want to consult layer by layer, for example, if I expand here, not the elements, but the layers. So here we could be able to see the layers, even for example, a particular element. If I double click here, sorry for the so here if I double click, you see the fiber board with the thickness and thermal resistance, or the insulation if I want to see the insulation. the insulation board with the thickness and the thermal resistance. So this is nice for the responsible of the project, the client, in order to see which elements or layers has been provided by the thermal designer, okay, or the MEP designer for thermal analysis. So let's move on. Now we are going to open a particular tool with the OpenBI instance. Here in the store, you have, for example, the Daikin OpenBI instance in order to VRV Daikin design, for example. In Daikin, if I particular is the OpenBI in Daikin design, okay? So this is in, here I have my library, I'm going to open it, OpenBIM Daikin, my shortcut is in, well, in a folder in my desktop. This is OpenBIM Daikin tool, okay? In order to see VRV design or aerothermal design. So VRV design, for example, webinar, okay? VRV webinar design. So I'm going to pick up the BIM modeling and also the thermal loads calculation from Cyberthermal loads. I'm going to select the project, okay? For now, it's clear, more or less, the process, no? I think that you are following me more or less. So what we are doing, we are just continuing step by step the different steps of the design. We have been designing the thermal loads analysis, the modeling, 3D modeling. Now we are going to select the equipment with this OpenBI and Daikin tool. Okay, so let's make a quick example, some part of the hotel, not the complete building because it's impossible. So, okay, well, it's going to take a little few seconds. Okay, this is the hotel and also the thermal loads analysis. We are going to read the thermal loads calculation for Cyberthermal loads. As you can see here, they are related into each one. They are linked between the different tools, different specialized applications. We are going to read the thermal loads analysis and the BIM modeling. Yes, you have some question? Go ahead. Yeah, I'm going to try to ask you while I have complete the import of the the building. Well, here I'm going to import all the floors of the building, obviously, and all the room types, space types of the building. I'm going to finish and the import to the OpenBIM Daikin tool. Yeah, if the architecture changes, that's the heat load count again. Yes, I will show you at the end how to see the changes between the model, the BIM model, and the specialized application. We will see that we have a tool in order to get to realize that the BIM modeler or the BIM manager has made a model on the architecture, and I have to update my thermal loads model, and I have to update my calculations. Okay, so I accept here. Yes, you will see. Just afterwards, I show you the example. I have to update the architectural changes. Okay. So the OpenBIM Daikin is reading the environment, it's creating the work environment, and is going to read the BIM model and the thermal loads analysis. So this is it. This is here we have the BIM model, and also here we have some layers. Also the BIM model, and also the thermal loads layer with the elements and the layers created by Cyberthermal loads. Okay. So there are the floors of the building. Here, as you can see here, with the different DXF or DWG, I could deactivate, okay, all of them. And we could see all the floors and groups of the building with the different, not constructive elements. Here, we don't need the constructive elements. We only need the rooms, spaces, and we need the loads. We need the loads. As you can see here, all the loads here, for example, for the different elements, okay? Here we have the loads for the different elements of here, for example, we have the toilets. We have, as you can see here, all the loads calculations, the total cooling load, the sensible cooling load for each hotel room. For example, in the ground floor, we have the lobby calculations here, the total cooling load, and here the cafeteria, for example, here, the dining room, etc. Okay, so this is the cooling loads. So first of all, we are going to establish the location data. from the same thing we have done in Cypher loads, Asia, Vietnam, Ho Chi Minh International, okay, for the outdoor conditions. Okay, so the general settings, this is important. In the general settings, in the the general settings is only show the image of the equipment, or really, sorry. In the BIM model, it's something you can modify here, the elements of the BIM model. If you want, we could do it, but normally we work in the environment, in the 2D environment. So we are going to make a design of the, for example, an example of different internal units. Let's start with the 6th floor. Let's introduce, for example, on one side, we have VRV systems here, outdoor units, for example. Let's introduce a mini VRV for compact, for example. And here in this is the Daikin elements. And here we have some equipment for each series of equipment from Daikin. If you see the log, this is in order to block it. If you block it, the software is not going to touch it. It's going to size it. If you don't touch it, the software is going to size all the design conditions, all the internal equipment is going to be sized automatically by the software. And here we can console the checks afterwards. So let's introduce some elements, this mini RV compact here. For example, this one. I'm going to place it here. And then we are going to place the different internal equipments. Let's move on to the 5th floor. For example, I'm going to place this inter-unit ceiling in the ceiling. And here I'm not going to pick up anything because the software is going to analyze automatically. For example, here afterwards we will see in a minute. In each room, let's see, for example, I could modify the orientation, this side, for example, another one here, another one over here. Okay, I'm going to do this side of the hotel, for example. And what else can we do? For example, we could also introduce a duct unit, VRV duct units here, a standard, high pressure, low silhouette, the different series of Daikin. This is like a BIM object, but we are going to make a global system with the global calculations. For example, let's orientate these purposes, on the other side, and we are going to place it over there. Okay, this is the internal unit for ducting, for make a ducting design in this area. Okay, so what else can we do here? We are going to copy this distribution, only this area of the units. We are going to copy from this floor to the rest of the floors of the building. For example, let's go to this functionality, copy from to another floor plan. And we are going to copy this distribution of units, okay? We are going to copy to the floor 4, 3, second floor, the 3rd floor, 2nd floor, and the 1st floor, okay? So we are going to accept here, and we are going to see, if we move on floor, we will see the different distribution of elements, okay? If we go to the 3D view, we could go 3D view in order to see the whole building. Okay, this is the 3D building with the thermal layers. Let's deactivate the thermal loads and the 3D model. And here you could see this is the outdoor unit, for example, this Daikin outdoor unit. And here we could see the internal units with the representation, real representation, the actual representation of the BIM object of Daikin for each elements. Okay, this is for each hotel room, and this is for the corridor of the each floor group. Okay, I'm going to, this is the distribution and placement of the internal and outdoor units. Here we could consult, for example, with this information, we could consult the information of the properties with this sailing unit, typology, and elements, okay, with this information. Okay, so let's close it. Okay, and let's continue. Now we're going to design all the piping, all the piping of the different elements. So for example, let's start with the, let's start with the 1st floor. and we are going to horizontal pipe without reference. I'm going to start from here. We are going to activate the ortho mode here, and we are going to design just up to here, for example, to this gain technique, this technical duct block through the different elements, the ducting design, vertical ducting, or the piping. Another horizontal pipe from here to here, and another one to here. Okay, so this is the placement where I'm going to design the vertical piping. Another option is from this internal unit for ducting design. I'm going to place it from here. Okay, this is another plan. So I'm going to make two designs, one for the internal units from the ducting design and other ones for the design units. If I move on to the 6th floor, I will see on one side, I will see the mini RV compact. I'm going to place another unit, another outdoor unit. For example, I don't know, this continuous heating, for example, this unit, okay, for these elements, I'm going to place it here, okay? So I'm going to, and now in order to place, to be able to place the verticals, I need to place the horizontal piping in the same position in the space in each plane where they are the other distribution of the piping of the rest of the floors. I explain myself. Here, I'm going to activate, for example, the distribution of the first floor, and you will see this is the internal units of the first floor, and this is the position where I'm going to place the verticals. Okay, so I'm going to use it in order to communicate with the 6th floor. Horizontal pipe from this point to this point. Okay, perfect. And from this element, I'm going to connect this one to this one. Okay, this is one of the units in order to communicate the rest of the internal units of ducting design, and another outdoor unit is going to communicate the rest of the internal units of sailing typology units. Okay, so now I'm ready to introduce the verticals because the position in the space in 2D are in the same coordinates. Okay, so I'm going to place a vertical pipe, vertical 1, for example. I'm going to place the vertical here, and vertical 2 here. Okay, perfect. If I save changes, I'm going to analyze automatically the design. Let's automatically size. I'm going to, with this software, it's possible to verify the results manually, update the results. If I'm going to block some particular dimensions, some particular power, total power, or anything like that, I can update results. Or even if I want the software to automatically design, I could use this tool. If I go to the 3D view, we will see here, let's deactivate, and we will see the internal units. Here we have, here we have the outdoor unit for the internal units for ducting. For the moment, I've only branched the first floor internal units, and also these internal units, sailing units for the vertical pipe for the other outdoor units. Okay, this is what I've done for the moment. Let's branch the rest of the floors, okay, for these verticals. So I'm going to second floor, for example. Let's deactivate, well, the first floor, it's going to be activated, for example, and I'm going to activate, for example, horizontal pipe here. Let's deactivate, for example, by bothering this one, first floor, okay. Well, I'm going to activate it in order to help me. Okay, I'm going to make another design in order to show you a little different design. For example, from this internal unit, I'm going to connect this one to this pipe and to this vertical, okay? And I'm going to connect this one to this one and for this one, okay? This is it. And for the internal duct unit, I'm going to use this unit. For example, let's make another design. Okay, just up to here and up to here. Okay, if I design again, the software should branch these units to the vertical I have already designed for the rest, for the initial purposes, the initial design. Okay. Okay, if I go to the 3D view, or even I go to the shortcut here, in the layers, I could deactivate the thermal loads and the thermal design, and here I could see the design of each floor, sorry, as you can see here, okay? All of these floors connected to the verticals. So let's go speed up a little bit, and I'm going to finish the rest of them. There are some mistakes, obviously, because they are not connected to the indoor unit to the outdoor unit, and the same thing for this one, okay? So let's connect horizontal pipe. I'm going to start, for example, from this one up to here, okay? From this one to this pipe and this pipe. And from this one, I'm going to, okay. Third floor, fourth floor is the same. Okay, perfect. And finally, just to the vertical, this internal unit, the other one also the same, okay? Fifth floor, the same one, from this one to the vertical, and from the internal units to the vertical here, and finally each internal unit to the different distribution pipe. Okay, so save the changes, I save the changes, and I size automatically again. I design again. We could make the process step by step, make designs or parts of the design, and automatically design or update results. If we want to check just if the changes I have made manually are complying with the technical data or technical requirements of Daikin. So here in the 3D design, let's deactivate the different floor snaps, visible floor. If I go to the 3D view, we will see the design. I'm not going to continue completing the whole hotel because it's very so much effort and so much work here, but you could see the design. We could see the information of the piping, the double gas liquid piping, and the connection with the two systems, outdoor units, with the different internal units for the ceiling and the ducting design. Here we could modify, consult the results, gas liquid piping, length and diameter, the outdoor units, and the internal units with the different requirements. Which checks that is going to make the software. For example, here for the outdoor unit, you see some checks, and this outdoor unit is automatically taken from this series, Mini VRV for compact. The software has taken the connection index and all the total nominal capacity and the console checks. If we consult, we will see the information of the specification here. The pipe length maximum according to Daikin, the real pipe length between the internal unit and the outer unit, the farthest, and the between the different joints, the branch joints also, and this is the automatic size. If I go to here, I will see the same verifications with the connection radio, indoor units, etc. For the internal units, very cool, because we have the cooling load capacity requirements from thermal loads analysis, and here we have that this equipment, there's the minimum requirement from Daikin VRV for ceiling unit, is complying with the total cooling capacity required, or sensible cooling capacity for these purposes. and the console checks is going to be required. Obviously, no heating capacity, even it's a heat pump and it's going to be able to supply heat. Okay, what else could we, what else results? Schema. This schema is very nice. This is really cool because we have the schema of the different VRV design. We have the heat pump with the joint derivation RefNet joints and the different internal units. According with the different diameters, the verticals, the gas liquid diameters, all the lengths between the different joint RefNets and the internal units. And also for the two systems, heat pump, one of the systems and the other one. This is also really cool. The reports. Here we have the results. We have reports and drawings with these icons or even with these elements. Project reports, VRV system. And here we have the index, project compliance with the different requirements, equipment list. This is really nice because all the quantities of the project, the Y joints or the RefNet joints, the tube lengths, this is all the quantities we have designed in the job, in the design. This is very important. You know, instead of doing manually by hand, this is very tough to do the quantities by hand. The software is going to take into consideration automatically. The other unit models, the other unit temperatures, in their units, etc. And the schema. Okay. For the both systems of the job. We could export in different formats as the same thing we have done in thermal loads analysis. And the material list. The material list is really cool also because we will have the possibility to obtain here in a really cool report all the list of materials. VRV with the representation, the beam object representation, or the real representation of Daikin for the different elements of units, internal units, and other units. Also, we could export the results to we could obtain, apart from the reports, the drawings in 2D, in DXF or DWG format. If you want to export to your CAD software, in order to customize anything, your schema or even your floor plans. For example, let's drawing show all the floors instead, except the ground floor. Draw templates. DWG formats. All the drawings of each floor in 2 dimensions are exportable in DWG, DXF, PDF, or in paper if you want to print it in paper or PDF or wherever you want to do. You could add a title block if you want from Zype or for your own, or layers. Manage the layers, the name and the color. If you go on, I'm going to export it in 2D. And we could generate these results in 2D formats. Okay, this is the aspect of the roof. Okay, here is the 6th floor outdoor unit distribution and each floor distribution with the different elements. There are some technical data that are customizable here by the user. We could print in here per file, all drawings in one file or per file, as you wish, in DWG or DXF format. Okay, and the schema also is portable. All of this data, if you want to represent in the drawing options here in general settings, I think they're here. The labels for the nominal capacity, reference type, model, etc. And the text size you can modify here the drawing settings. Okay, so this is all the data you can modify here. What else? Let's export the results to the BIM project, and we are going to finish with the ducting design, okay, of this project. The accept drawing, reports, and quantities. We accept, and we are going to generate all these elements of the results. Remember, of the OpenBIM workflow here. We are working with. We have worked with IFC Builder. We have worked with Separate Loads, with OpenBIM Daikin, and we're going to generate the technical documents and export incorporates to the BIM model. We accept here, Okay, drawings. So warning for the results, the different formats for the drawings. In IFC formats. Okay, perfect. And now the synchronizer should be synchronizing the project in just in a few seconds because the results are exported here. Okay, perfect. It's exporting the information of Daikin, OpenBeam Daikin HVAC installation from this application with the synchronizer, uploading the information to the BIM project. And just in a few seconds, we will be able to update the results in the project tab. We will go to the webinar HVAC and we will see the information for in the 3D and also in the files tab. For example, in the files tab, we will see the information HVAC installation. You see all the results generated by OpenBeam Daikin are here with the HVAC GLTF, the drawings in WG, the material list, the quantities in VC3 in order to communicate with Archimedes for the quantities and the budget, and the VRV PDF, for example. This is the PDF, the results from the results PDF that you have seen in OpenBeam Daikin. Directly, we can consult, even the client or the contractor can consult here in the platform if he's invited to the, or even you, if you are in the project inside, you can consult the information directly here in the information on the platform in PDF, or download or print it, or whatever you want to do. Okay, all the team members of the file are going to be able to consult the information. And the GLTF, obviously, if I consult here, the GLTF installation, this is the 3D of the HVAC VRV design of OpenBeam Daikin of this part of the hotel. Okay, really nice. Okay, let's finish with the ducting design. For example, let's imagine that we could make for example, a particular design for the exhaust of the toilets, for example, and a particular supply design for the internal units. And in order to do that, we are going to use another tool that you could find here, Syptherm HVAC, in the whole global Sype suite, or even in the platform, in the store platform, you could find Syptherm HVAC. Okay, for the ducting design. Okay, this is the HVAC design. Let's create, for example, ducting webinar design. Okay, let's accept here. Import a BIM model, yes, because we are connecting with the OpenBeam technology. This is the wizard. Let's select the project. This is the same procedure as you can see. In order to create a new native file from each specialized application, we have to connect to the BIM project. We have been invited, or we have created ourselves, and we can create our new file. Webinar HVAC, we are going to click on next, and we are going to read the BIM model, the thermal loads analysis, and also in the 3D, we will be able to see the VRV design of the OpenBeam Daikin equipment. Let's minimize this. Okay. Okay, this is the 3D, the BIM model. Okay, additional Syptherm loads and OpenBeam Daikin. We are going to read and search for typologies. We are going to, from this typology where I have my libraries, if there are some libraries of diffusers or grills or just rooms spaces, I'm going to read them in this import process. Finish the import. Yes, what there's a question, when design water chiller system by site? Yes, water chillers. We have some, well, today we don't have time, but here in the store, I encourage you to test for water systems. We have another tool here. You can search for SAP HVAC, okay? And for SAP HVAC, we have SAP HVAC Hydronics. This is for water systems. And you could define the primary system for the water system piping design in connecting the a chiller and between the chiller and a fan coil or a air handling unit or whatever internal unit in a water system with a chiller. Yes, with this software you can design the water distribution installations between the outdoor units like chillers and wherever air handling units and fan coils or whatever other system for water systems distribution. This is the software. I encourage you to test it. No, can convert another can convert VRF to water chiller system? No, it's not possible. Because one thing is designing a VRF or VRV system is one thing, and a water system is another completely different system. Okay, so this is the really different. So there are separate modules and separate, totally, completely different systems. Okay, but you could introduce in the same project, in the same VM project, you could work with SAP HVAC Hydronics or OpenDecker or whatever VRV or VRF systems and design both systems, water or VRF systems, if you want to compare or whatever you want to do. Okay. Well, this is the HVAC for ducting design. Let's import all the floor groups and all the rooms spaces, and let's make a quick ducting design before finishing the webinar. So let's accept here. Okay, the software is creating the work environment. It takes a little time in order to configure it because this is a very complicated building. Okay, so this is the work environment. As you can see here, this is very similar from the rest of them, the tools we have. This is the thermal hotel. Here, this is the hotel building with the here in HVAC design, certain HVAC for the ducting design. We could see the the equipments for the open beam dicing and the results for the also thermal loads analysis. Also, the thermal loads analysis are taken from the thermal loads. For the also the ventilation flow taken from the thermal loads analysis, the ventilation flow, and also the thermal loads analysis. Okay, let's make a quick design for exhaust design. First of all, I'm going to establish, well, here are general settings. We can configure, for example, the type of rooms. Here is very simple. For example, machinery room, there are no cooling, no heating. Office, it's only cooling. For example, the toilet is only cooling. Unconditioned, not cooled, not heated. The lobby, it's only cooled. Only cooled. The corridor is only cooled, for example. Cafeteria, only cooled. Kitchen, only cooled. And laundry, only cooled. Okay, so all the space types of the typologies are already imported here. And here we could import, for example, there are many different equipments, variant floor, ducting, thermal emitters, some equipments, but we are going to just ducting design. In ducting, we have this predefined galvanized steel plate, or we could create another one, glass fiber, for example, from this predefined type of ducts, glass fiber, aluminum, flexible ducts, or PVC. I'm going to use glass fiber. I'm going to import, for example, grills, supply grills, for example, 3 or 4 typologies, but you can create your own supply grills with all your own technical data or your technical supplier or your own local supplier or manufacturer from your local market, you could create your own supply grills and create your own libraries. Also for exhaust grills, I'm going to import from some predefined exhaust grills from my library. And here we can edit and modify some parameters if you want to create these grills. And also just it, I think that's it. Some parameters for the connection, the design options for ducts, the maximum velocity, maximum pressure losses, and also some parameters for drawing options and with technical data you want to provide in the ducting design or the grills or diffusers. So let's start with this first floor. I'm going to, for example, let's introduce some ducts from glass fiber and also exhaust, for example. And the rest of the analysis of the taps is going to be automatically sized by the software. I'm going to design from this element just to this, for example, and from this point just up to this. I'm going to place the grills, exhaust grill, for example, with a parameter of, let's imagine 32 liters per second, for example. I'm going to place this element here and the other one here, okay? Now we are going to introduce a vertical duct from 2.50. Well, there are some 2.50 from the first floor. I'm going to get to the 6th floor, 1 meter above the 6th floor for this glass fiber rectangular and exhaust ducting, okay? And we are going to place it here. Okay, this is, for example, an exhaust design. Let's do the same for the supply design. For example, let's introduce a glass fiber supply network, ductwork, and here we are going to start more or less here, where it is going to place where we placed the internal units, and we are going to reach up to here. We are on the ortho mode, for example, up to here, and with the ortho mode up to here, for example. And now we are going to place the supply grills with these dimensions, for example, and we are going to 110 liters per second, for example. I'm going to place one supply grill here, another one here, another one over there, another one over here, for example, another one here, and another one over there. Okay, for example, this design. I'm going to save changes, and we could in the 3D just refresh it before analyzing, and we could just represent the 3D. This is the ducting exhaust design with this only this element, these toilets from the first floor, and the supply design from the first floor also. What else can we do? In the diffuser duct, any noise level criteria? Yes, with in general settings, for example, for the grills or diffusers, if I import here, any diffusers, we could edit and just the sound pressure. There are some criteria for sound pressure elements or parameters for sound pressure and noise on drops. So it's possible to make some criteria about the noise criteria level of the diffusers. Okay, it is possible to do it. Okay, so let's go to the, let's copy this design to the rest of the floors. For example, straight ducts. I'm going to copy this whole design. Okay, this whole design of the supply and the exhaust design. I'm going to copy this design from the first floor to the 2nd, 3rd, 4th, and 5th floor. Okay, so if I refresh the 3D view, I will see all the designs in the different floors. I have copied from groups. Okay, So let's save the changes and try to size automatically. Here we have the same possibility of open beam dicing. We can update the results and verify if we comply the results or requirements of the design, ducting design, or if we size automatically, the software is going to size automatically this network. Okay, so if I size automatically, this is very nice because we are going to size automatically the fittings. So we are going to size, and let's see if we comply the requirements. There are some warnings because we don't have warnings because there are some designs that are not complied because we don't have any particular design here. But for the rest, we have first floor, we have all the elements. And this is what I love it very much. This is all the designs of the ducting. Here you have the ducting. For example, let's consult some particular parameters. Here, check that. We have some parameters on the screen. We can click and consult the checks. We come here, consult the check, and this is very nice. All the theoretical criteria of calculations with the Al-Sul-Sal formula with all the pressure losses here for the different stack ducts, the friction factor, also the Reynolds number for the calculation with ASRAE ducting design criteria, hydraulic diameter, the equivalent round diameter, velocity pressure, and the section. This is very nice, and this is the verification, the checks we have duct by duct, piece by piece in all our ducting design. Okay, this is really nice. Also, this is what I like very much for the pieces, the fittings. We can click, and here we can see the code, ASRAE ducting design codes. If we consult the checks, we could see the code ASRAE design for the pressure losses or the pressure drops according to the regulations of ASRAE codes. Is the pressure drops 2 pascals, for example, for these pressure drops for this piece or these fittings. Duct fitting design, this is very nice. So this where I like it very much because the fittings, to generate the fittings automatically, is even you can customize, you can move bulkhead, rectangular or circular, even you can modify the inlet, the branch, the angles for some particular ducts. For example, this is the transition. And other things you can modify or consult the checks for the fittings. This is also very nice. And in the 3D view, you will see this representation in 3D. And this is also nice. Well, I'm going to pass it here. Let's deactivate the 3D model. And here we have the design. Here we have all the ducting design for the exhaust network and the supply network. For the supply network for these elements. We can consult the information, the double branching, fitting, all the pieces of duct, the dimension reference flow, and all the grills with the flow, the reference, all the transitions, elements, the ducting design, the duct sailing elements, the grills, supply grills, and for the exhaust network, we have the same. Here, the network for the straight duct, the exhaust grill, flow, etc. Okay. This is for them. Which reports we can obtain or we can get? The same thing, reports and drawings. In the ducting design, we have the checks of the ducting pressure drops and all the verifications, total linear pressure drop, total loss of pressure, accumulated pressure drops for each pieces of element, okay? With the transitions, the fittings, the straight ducts, with all the elements verified here. Okay, this is very nice because all the fittings and all the straight ducts has its own particular checks and is all justified. And the material list is also nice because we have all the quantities of each element, all the exhaust grills, all the supply grills, and the material glass fiber for the ducting rectangular elements. All the square meter fiber boards the glass fiber boards that we need in order to configure this ducting design for the exhaust and the supply that work. We could obtain also the drawings in 2D dimension in DXF or DWG. We could export the fittings, and we could export the results to the BIM project. And also, well, in order to end with the webinar today in the presentation, I'm going to finish with one question you have done before. Well, I'm going to show you the results exported to the platform. Once it's informed that everything is generated here. Well, the drawing selection, let's establish, yes, except the first floor, all the rest of the floors. In 2D, the XF DWG files. Okay, everything is exported. And now in just a few seconds, the software is going to export synchronize the project with the platform. And if I come back to the platform project tab, remember this one, with a Control F5 in order to refresh it. I could go to Webinar HVAC, and we could see the results of HVAC design. Files. In Files tab, we will have now, yes, the HVAC installation from ducting design. Well, this is the reference I've introduced by default. I could do it. I could have modified by ducting design or something like that. This is the ducting, the GLTF, the PDF, all the quantities, the drawings, and all the ducting design from this network. Okay. All the PDF ducting, the material list, etc. Okay, so this is it. So, and in order to finish, yes, if we come back to the IFC Builder, this is the original 3D model. I can update it here. If I go to this tab, instead of exporting, I can update, and the software is, as we are connected to this Webinar HVAC project, we can see the information results of open beam diking and HVAC and loads design. And we can update the results from the different specialized application to this the BIM modeling, this here. And in the 3D view, we will be able to see, apart from the 3D view of the BIM model, or the modeling here made in IFC Builder, we will have the possibility to consult the thermal model, also the open beam diking design, and the ducting design from SEP Thermal HVAC. Okay, so here I'm going to show you. Okay, here it is. And this is the design we have done. I have shown you with the different elements, the BIM model we have been added here. We could deactivate all of this and just activate the BIM model. This is the architectural modeling we have in IFC Builder, and this is all the BIM model we have defined in the different specialized applications. Imagine that you have done also plumbing, also fire protection, also sanitary systems, lighting design, etc., etc., etc. So we could complete the whole BIM project here. Okay. And as for the question of one of you that you told me about the architectural design, what happens if the architectural designs changes? So here in the this is the original BIM modeling. For example, imagine that for example, let's imagine in architecture, I'm going to here in the bottom on the right, we are in the 5th floor. And if we go to for example, the ground floor, let's do it in the ground floor. Here, I'm going to just remove the edges, because if not, it's going to, okay. So what happens if I change here? Remember that, for example, in for example, where I can do it is, for example, in open beam diking or in thermal loads in open beam diking, for example, here in the ground floor, as you can see here, this is the results, okay, of the different elements, okay? This is the results of the architectural design. So what happens if I change the architectural design? Let's imagine that I remove in architecture space select this the cafeteria is going to take up from here walls and partitions. Let's delete this wall, and I'm going to introduce a partition with these elements, for example, here. Okay, and also I'm going to, for example, in this wall, I'm going to introduce in this wall a whole window. For example, let's go to openings, external carpentry and close openings. Here, for example, let's introduce, for example, or a new one, window one for the width and the height 1 meter. Okay. So if I introduce here, okay, well, I'm going to edit, for example, the ground height above the ground level is going to be 0.30 or 30 centimeters, and here is going to be 2 meters, for example. Okay, in the 3D view, we will see this design changed. This cafeteria, for example, has changed. Let's introduce everything, and here is the new cafeteria, for example, with this window. So I'm going to update results. Let's analyze the result. I'm going to export again to the BIM project. I'm going to analyze the geometry and export to the BIM project the whole building. As we are finishing, if anyone has any doubt or any queries or any feedback about the seminar, I'm showing you how to update the architectural design. I'm going to export now. We have analyzed export with the same project, BIM project, the same name, and we are sorry about it because sorry about it. Well, let's save it, export again. Okay, I'm going to change it because some problem about the permits, probably. I'm going to open IFC Builder again. Anyone has any doubts or any queries about it? More or less it's clear. The idea of today was just show you an overview of the workflow, how to create a BIM project, how to work with BIM Service Center, how to create a profile and a BIM project, how to create a new model, a 3D model from an example from zero, from IFC Builder, export to the BIM project, and then communicate with the different tools. Cybertherm loads for the thermal load analysis, Cybertherm open beam diking, for example, for VRV design, and Cybertherm loads for thermal nodes analysis, open beam diking for the VRV design, and finally the Cybertherm extract, for example, for the ducting design. This is more or less what we have done, and the process we have followed. I just wanted to show you the update of the architectural design. Anyone else has any doubts, or everything is more or less clear? I'm sure that in the future we will have any whatever doubts or queries. If you are going to test it or to work with our applications, I give you our technical support department is support@sype.com. Whatever technical consultations, if you register in BIM Service Center and you are going to test some tools, or if you want to ask any questions about the use of the software, about the installation, about the calculation, the result, etc., you could ask us by this support@sype.com address. Well, here is the results. I'm going to export to the webinar. I don't know why maybe it's some kind of privilege about the software. I'm going to close. If not, I'm going to show you in some video tutorials. I'm sure you will be able to see this option. I'm going to open it. Finally, I'm just going to make a final design because maybe it's something about the run as administrator's permits is very important, because if not, sometimes the software is not going to leave us the possibility to do this. I'm going to close this one. IFC Builder. Okay, so again, hotel again. And let's see if now we are able to just export the results to the platform. It shouldn't be the error shouldn't be because the tools are open, because imagine that we are working with different. Yes, now it's possible. Maybe this run some administrator permits. Now it is possible. You see. So because I didn't run as administrator, normally when you run the applications site YP, you should run as administrator. So be careful with that. I'm going to open, for example, HVAC. So now we have exported with the same file, the same project, and now it's updating this Synchronizer. As you can see, the 3D model is updating. And now in the webinar design, no. Okay, well, I'm going to reproduce the previous situation. So what I was saying, sorry, the separate loads, opening bin diamond, or whatever applications you have in your computer, it shouldn't be a problem if you update something in the platform, because normally imagine that you are working in a collaborative process and we have to simulate different purposes, that you work with different people in different offices in different places all over the world. So we are working in a cloud server solution exporting the results, so it shouldn't be a problem to update. So here, this is what I told you. This is the previous ground floor design. Remember, this is the cafeteria before, but here we have an update result. And as you can see here, the import file associated with the BIM model, we have a warning here that we have to update the BIM model because the architectural model has changed it. Because the designer of the architectural model has changed it. This is what some of you asked me some time ago about the architectural changes. How do we count, or how do we take into consideration in the thermal loads analysis or in the HVAC analysis or wherever regulations, whatever applications. And here, now we will see okay, we are going to update all the elements, and now you see the cafeteria, new cafeteria with the new design. We update results, we finished, and now we will see the modification of the cafeteria. Now, if you realized, okay, this has changed. The new cafeteria with the new window, with the new huge window here in the BIM model. If I activate the BIM model here, you will see the new BIM model with the new window and the new design of the cafeteria. Okay, so this is the design. And the new surface with this wall I have modified here. This is the way we update the different we could do the same with Cypher loads, with open beam diking, the rest of the elements that are connected to the beam project. Every update results we are going to see in each application. Okay, so this is it. I hope that is understood, and the way to update the result when the architectural modeling has changed. Also, when someone exports to the platform, the rest of the people is going to see the remarks that is going to be updated. As you can see here, for example, the HVAC installation and the modeling has been updated, and I have to update my modeling. Okay? So anyone else has any doubts or queries, or I'm sure that you are going to test, you're going to work with the software and with the applications, and I'm sure you, in the future, you will find some troubles, some doubts, some queries about the use or the results or the installation of the software. Anyone else have some comments, some feedback to do about the webinar, about the tools and the workflow or the applications? Well, thank you very much for your attendance today. Thank you very much for your patience. I hope I hope to have been helpful to you, and I hope to see you to be in touch in the future, and I hope that you start working with the software. And if you find some troubles or some doubts, don't hesitate to contact us. Yes, I'm sure you will. Thank you very much for your comments. Your feedback is very nice. We will appreciate your improvements, your comments in the future in order to improve. This is a live software, living software, and we hope to be in touch with you, and in order to see your needs and your requirements for your codes on your countries, on your wherever you are. So we need your feedbacks and your comments to improve our software. This is very nice, but for your patience and your attendance today, thank you for your comments and your words. Yes, I hope you need time to work and you're gonna feel later. Yes, sure. If you change the IFC model design, change automatically. Yes, if you update the model, the architectural model is going to change automatically, and the results of the different elements you are going to automatically charge in wherever applications. For example, if you change the architectural model in Cypher loads, you have to update the beam model, and then you have to update the results here. The same thing and if open beam diking or HVAC design. You have to update the beam model, and then you have to update the results or redesign in wherever applications you are working with. But the beam model is going to automatically be updated. Okay. Okay, thank you very much for you. Take care of you. I know the situation is really complicated for all of us. Take very care of you, of all your families, and all of you. And I hope that we are going to overcome this situation we have all over the world. I really appreciate your attendance today, and I hope to see you in the future. We will be able, me and other people from the technical support department of CYP, we will be in touch with you with a few further seminars, webinars, or wherever other situations or whether technical consultations. So I hope to be in touch with you. Take care of you and have a nice day or have a nice rest of the week, and see you in a very few time. Okay? Bye-bye. Bye.